So as they mentioned, my name's Leigha Mitchell. This is Ed Robinson. We can be found by our handles there on pretty much everywhere. And today we're going to present time for a change stream. So this talk is going to be about change streams and how we use them to version our data at Hubba. So what is Hubba? As it says here, Hubba is like a dating app for retailers, buyers, and brands. Basically, it's a platform where thousands of verified retailers can reach out to thousands of verified craft brands, and they can connect and sell products amongst each other. Currently, our stack is meaner. So we started with Mongo, Express, Angular, and Node, and we recently introduced React. We have a lot of different microservices. So payments is one, products, users, things like that. We have 3 engineering teams. 2 are JavaScript on the front and back, and 1 is our Python team, and that's mostly business development. Business tech. We use AWS, Google Cloud Platform, MongoDB Atlas, of course, RabbitMQ, Redis. Our ORM is Mongoose, and we use Mongo native driver as well.
So what is a change stream? Mongo introduced change streams in Mongo 3.6, and it's a way to subscribe to real-time changes to your data. And so this takes away the complexities of tailing the oplog to do this. The oplog in Mongo is how databases sync. So if you've got 3 nodes in your kind of cluster, the oplog is actually how those 3 databases will communicate and stay in sync. But change streams take away the complexity of using the oplog to find out what's changing in your database and action that.
So why are we here? As mentioned, we work for a company called Hubba. It's currently 7 years old. So that gives you an idea of how big and how much spaghetti and legacy code we have kicking around. It's a platform originally for networking for these brands and buyers that we talked about. And we have a lot of different microservices, like I mentioned, so you can kind of get an idea of what our code base looks like. And recently we decided to launch ordering so that these verified buyers can purchase and actually order through Hubba from these craft brands. So with ordering came a lot of different decisions that we needed to make, but the must-haves were basically that the exact product you ordered has to be the one that gets delivered to you. So if a product description originally shows a ring like this with Elvish encryption, but then the brand goes and changes that to this boring old wedding band, then we need to know that that change was made in the product description and capture that data in our database.
So what exactly is a version? We all use versions every day as developers, right? When you make a commit to Git, that SHA that you get back is that version, right? When you install a package via NPM, that number is a version. When you're talking about Mongo 3.6 versus 4, that's a version. However, when it comes to our data, a version is a particular form referencing a snapshot of that data in time. And so at Hubba, when we first create a product in our database, we call that version 0. And then whenever we make an update to that product, we increment the version number. And so the user may update that description from an Elvish inscripted ring to change it to a simple wedding band. And we would bump our version then from 0 to 1. And then if they reverted that change, we would go from version 1 to version 2.
So we decided to start versioning when we were introducing ordering. We had to look at our options. So I'll get into these a little bit more, but at a high level, they were not versioning, so we could just not do it. We could make a copy, but we found it was a little hard to figure out what to copy. In-app versioning, so we could lean heavily into Mongoose and version the app, or we could use the oplog for versioning. So the first thing we looked at was not versioning, so just not doing it. So in order to not version these products, what we would have to do is once a brand created a product and added it, they just couldn't edit it after that. It had to be what it was, and they couldn't go back and change it. If they wanted to make any changes, they'd have to create a whole new product. Obviously, that's not a very good user experience. People aren't used to working that way, so it just wouldn't work for our customers.
So the second version we looked at was just making a copy. So whenever you added an item to your cart, we would make a copy of that. We would store it on the order model, and we could use that as the canonical version of what you ordered. There was actually some significant challenges, though, when looking at this solution. If a user adds something to their cart, but between them kind of adding something to their cart and the page they've seen, the user actually updates their product, we can't copy it from the database because the database wouldn't have the correct version of the product that they were adding to the cart. Similarly, we could have had the front end post to our service and say, hey, this is the exact document of what I'm trying to order. But then we'd have to trust the front end, and a malicious user of our API could actually post an incorrect product. We could sign it or something like that, but even then it's a lot of data going over the wire just to support versioning. And so we opted not to use the solution for those reasons.
Then we looked at in-app versioning. So this would have worked great if we were building something from scratch, but given that we have so many different teams, we have so much legacy code, we also use a lot of Mongo raw queries, which I'm going to get into a little bit later. So in this case, for a raw Mongo query, what I mean is it's a query that we're using that's not created by our ORM mongoose. An example of this would be mongoose would do a model.save, whereas we like to use db.getCollection for users, and then we would update and set the name to Frodo. So this is a pretty heavy slide, but basically we use a lot of denormalization strategies. So this is good for us because we have a lot of things that are read, and it increases read performance by adding redundant data to a normalized database. So when something is read a lot more than it's updated, we like to use this strategy because it helps us avoid a lot of application level joins, like it says here. So an example of this, here we have our 2 users. So ID1 is Frodo. He's currently unemployed. This is before their adventure. And then we have ID2 is Sam. So he's also unemployed. And then here's a message thread between the 2. So as we can see, ID2, so Sam is messaging Frodo. He's asking him, what do you call a hobbit party? And Frodo's heard this one before, so he replies, a little get together. Hold for applause, no applause. So after they go off on their adventure, now we have to update our Frodo's occupation to bearer of the ring, and we update Sam's occupation clearly to protector of Frodo because he doesn't know what he's doing. And in our message thread, now we see that the occupations have updated. So in the first part, ID2 is going to be Sam, and his occupation is now changed to protector of Frodo, and he's messaging Frodo, who is bearer of the ring. So if you want to go back for a sec. What we would have used is the message.update and then object ID 1, for example, and then we're setting the occupation to bearer of the ring for Frodo.
And so Leigha and I actually attended MongoDB World last year, and we actually met a bunch of companies that were using the oplog to do event streaming and things like that. And this was the last option we kind of looked at. We looked at this and we said, what happens if we just tailed the oplog like any other database would do? And we could see insert events, we could see update events in our database, and then we could just copy those events out and create a version, right? And we could use that to version. And so we looked at this, and this actually did appeal to us a lot, but.
So what did we choose? As you might have guessed, none of them, because we're here talking about change streams. So along came Mongo 3.6, and we started to look into this new thing called change streams. And why did Mongo 3.6 appeal to us? First of all, we could do versioning very easily. We didn't need to make any significant architecture changes to implement it. We could keep those fun raw queries that we love so much, so it allows us to keep our denormalization strategies. And then we could keep many sources. So none of our front-end data consumers from all those other teams we talked about needed to be altered in order to support this versioning.
And so we decided we would use change streams to version our data. And so this is kind of a very simple diagram of what our services would look like using change streams. So we would have our website. We also have a mobile app. But in this case, we would have our website. And our website could talk to the product service to get information about products. It could talk to the ordering service, so it could order products, right? Add products to an order, see previous orders. And then we'd have this history service. This history service would talk to the ordering service so that it could then say, hey, does this product exist? And it would talk to the Mongo database so that it could listen to our change streams. But the history service would never talk to our website. And so what did an example of creating a product look like using change streams in this new format for Hubba? So you can see here we've got our website, and it decides to create a ring. And it reaches out to the product services, and it says, I would like to create version 0 of this ring. Our product service then reaches out to our Mongo database, and it says, can I create version 0 of this ring? The Mongo database would say yes. It would return back to the product service, which would then return back to the website. But the really cool thing about Mongo 3.6 and change streams is at the same time that Mongo is saying, yes, I can create this product, and returning back to the product service saying, I've successfully inserted this record into your database, it's firing a change stream event saying, an insert event happened in your database, and this is what happened. And so the history service is able to listen to that and then have an exact copy of the product that was created from the product service without ever talking to the product service. And similarly, when you were to order a product, we would do something very similar. So the website reaches out to the ordering service and says, I would like to order this product. The ordering service is able to reach out to the history service, but now what it's able to say is, does version 0 of this ring exist? Do you believe that this is a version that we have, and therefore we can display the previous version to the user? And in this case, the history service says, yes, you can. It tells the ordering service that. And only at that point would the ordering service reach out to Mongo, insert the record into our database, and then return back to the user.
So I know you're thinking, what about those wonderful raw queries that you love so much? So our version numbers are actually human readable and SHA. So as you can see, this 42 here means it's the 43rd version of this product. And then we have the hash that follows.
And so what does a change stream actually look like? I know that's what you're saying. Like, it's great and all that we're able to send data back and forth, but what is this change stream event that you're listening to? When you subscribe to a change stream, every single time there's a change in your database, you're being guaranteed to get an event that looks like this. And so there's 6 fields here, and we'll just go through them all very quickly and kind of tell you what they do. The Mongo documentation on this is actually great, and so if you want to know a little bit more about how they work, I would suggest you go there. But very quickly, the first thing in a change stream is an ID. And this one's actually kind of the funniest one, because it's not a traditional Mongo ID. It's actually a BSON object. And you can actually use that object to resume your change stream. And so in our case, if the service that's listening to a change stream goes down for whatever reason, the second it comes back up, it just finds the most recent event it has, and it basically says, I want to resume listening to the change streams from this point in time, and Mongo is able to handle that seamlessly for us. The second thing is the operation type. This is generally the operations that we're all used to seeing. So we have our insert events when we're creating data in our database. We've got our delete events when users are deleting their products. We've got our update events when a user is changing the description of that ring. And then you've got your replace events. This one's a little bit funny. It's really just an update, but Mongo is, instead of saying, hey, I've only updated the description, it's saying, I've updated this document, and this is what the new document should look like. Ignore anything that was there in the past. This is what the new document looks like. And then the last event that we listen to is an invalidate event. This happens when a change stream becomes unavailable. The examples of this are, if you deleted a collection, Mongo would fire an invalidate event. We're not deleting our products our product collections at least at Hubba, so that wasn't actually a big issue for us. But the other events we do listen to. The full document is actually super cool, and this is what got us really excited about change streams. There was a little bit of a gotcha that we'll talk about later that we had with this, but the full document is the full document that has changed. And so whether that's an insert or an update, Mongo will actually send along the full document that changed with it. Then you got your namespace. Wonderful variable name are here, but you got your namespace, and this is just the database and the collection that changed. And so for us, this would be, the database would be Hubba, and the collection would be products. Or the database would be Hubba, and the collection would be orders, for example. Document key is just the ID of the document that changes. And then you got your update description. This is a document consisting of 2 fields. One is a map of updated fields, so it will say things like the version got set to 1, the name got set to Leigha, and then the other one's a list of removed fields. So if your schema changed or you removed an element from array, that would be listed in the removed fields. So what do change streams actually look like in action? Just like Leigha, I'll hold for giggles.
Yeah, giggles.
But anyways, if we insert a message into our Mongo database, you could see here we can insert a message, and we could say this is from user 2 to user 1. The occupation in both these examples are unemployed. And to use Leah's example from previously, the message here is, what do you call a habit party? I guess Sam has made a typo this time, and we'll go and we'll fix that typo later so we can look at what it looks like. But on the right here, you can actually see this is the document that we'd insert into our database. So it's got an ID, a from, a to, everything that you are used to seeing. However, on the left is the change stream event that will be fired when this document has been inserted into our database. And so you can see that ID there, which is that kind of not very human readable BSON hash. You've got your operation type telling us that it's an insert event. You've got your full document, which would just be the document on the left. You've got your namespace, which is Hubba, and in this case, the collection is messages. And then you've got your document key, which is the ID of the document that's inserted. You would also have a change here, but the change isn't anything, because you're just inserting the document.
So here's what this would look like in our database. So as you see, we've got the ID, our changed version. So the document version is currently 0. We have the hash version, and then our wonderful joined version there. So we have the human readable and the hash version. We also have the document ID. We have the nanoseconds that it was received, so we can track it when we're doing ordering. The change event is saved as a string there, and version 0 again. And then the object is the full document, under document.
And so what does an update look like, right? So Frodo has found his typo, and in our example messaging app here, we're allowing you to edit your messages. And so Frodo could actually go in and change his message from what do you call a habit party to what do you call a hobbit party, so we can get the joke correct. And in this example, we would fire a update query into our database, which is updating that message. And so you can see here again on the right, the document that we would have after we've updated it is just what do you call a hobbit party. But the cool thing is the change stream event that happens here. So the ID, again, is going to be that BSON object that we're used to seeing. The operation type is an update. The full document would just be the document on the right. But the update description there, you can actually see the update fields. And so the updated fields here are the message, which is now changed, and the version number, which we've incremented from 0 to 1. And then in this case, we're not removing any fields, so there's not going to be any fields removed.
And then that's what this is going to look like now. So we see the document version is updated to 1. Our hash has changed as well. So the joined version is now 1, and then the new hash. The document ID, the nanoseconds again, our change event, version 0, and then the event is now, the operation type, sorry, is now an update when previously it would have been an insert.
Cool. So we read all this. We thought this was all great. Now it came to implementation. We work on 2-week sprints at Hubba. And we actually built our first concept in 2 weeks. So to build this first proof of concept, we purely just listened to the full documents. So whenever a change event happened, we take the full document out of that change stream event, slap it in another collection, and be like, we think this is the version that we have. And using this, we were successfully able to mirror all the documents that we have, like all the products, all the orders that we have in Hubba. And we were very happy with the solution.
So our first gotcha was the principle of eventual consistency. So this happens when a document's updated many times really fast, and it's because, so the full document, wouldn't always represent the document that existed in the database because of this. And it's because, sorry, I'm just trying to check what it is. Change streams can be configured to only send when the document is durable. However, the full document only comes from a single node in our cluster.
And so Mongo actually does mention this in their documentation. Just like I don't read emails, I'm also not the best reader of documentation. And so we actually found this out live, right? But what a full document is when it comes in a change stream is it's the full document that has become durable. But if, for example, you're doing writes very, very quickly, you can actually have 2 documents becoming durable before that event's been fired. And in that case, you'll get a change stream event with a full document that doesn't actually match what's been updated. And so if you're going to use change streams, or you're going to use Stitch, or you're going to subscribe to them, make sure you know that full document existed at some point in time, but it's not necessarily the full document at the time of that change stream event. But the solution here was just be more like Mongo, be more like a database. They're already giving us that update description anyways. And so what we chose to do is when we received an insert event, just insert the full document, because we know that's the first time that's ever happened. But when we receive an update, we'd actually go into our histories collection, find the previous document, and just apply that update to the full document. And this allowed us to always have the exact document that was in our database at that time.
So our next gotcha was, like I mentioned, Hubba is a 7-year-old company. We have a lot of old data. So with a lack of insert events for all these records, how are we going to get them into our shiny new history service?
And so this was a problem, because before we were relying on the full documents and everything was great, and now we weren't, but we had to get some of that old data into our database. And the solution here, again, was pretty obvious. It was pretty, not obvious, I would say, but it was pretty intuitive once we really understood what was going on. And so we opted to, if we can't find the previous version of a history event, just use the full document. We'll treat it like it's an insert, even if it's an update. What that does mean is, in the case where we were rapidly updating our products, that document would not be correct. However, it would calculate out to a different SHA. And so our product service would never reference that because it wouldn't ever be referenced. And then what we would do is we just built a cron job that would go through our database and make sure that the documents in our histories collection actually existed in production. And if they didn't, we evicted them. And using this strategy, it actually took us about 1 week, but we were able to get all of our products to have history versions that are correct. And once they were in that state being correct, we know all new documents will come with inserts. And so our data was able to update just normally. And so now our database looks like it would if we had this solution from day 0.
The next one. So we needed to look into and make sure that each record we had was going to write only once and in the proper order that we needed to write in.
And so this actually is pretty easy with change streams. Change streams are guaranteed to be delivered in order. So you know the relative time that a change stream event was fired. And then in Mongo 4, they're actually going to give you a database time that the change stream happened in. It's not going to be a timestamp that you can rely on, but it will be an orderable timestamp so that you can know one change stream event happened from the other. And so what we do at Hubba is right now we're running on 3.6. And so whenever a change stream event comes in, we record the time in nanoseconds that happened. And then that's our relative timestamps that we use to order our messages.
The next gotcha that we were curious about was if we had documents that were too large, it was going to cause us some issues with using change streams.
And this is obviously an issue. And so our answer was don't do it, right? We're storing additional metadata around our versions in Hubba so that we can reference them, so that we can look them up by SHA. And if we had a 15, 16 megabyte document, obviously that wouldn't fit in our histories database. And so the answer really there is don't do it. There are options we could do where we split the metadata out into its own collection, but all of our documents at Hubba are under a meg. Keeping your documents small, I think, is a relatively good practice. And so don't do it.
And then we fell off the oplog. So if your oplog can hold 100 documents and then we start sending 101 messages, we won't be able to resume the product's change streams.
And this is the other big gotcha with change streams, is that because you're using the oplog to propagate those changes, if you're, heaven forbid, you didn't get an order for a long period of time, or if your service went down, and when you tried to resume it, that BSON ID didn't exist in your oplog, you actually can't resume. And so the solution here was we got a bigger oplog. We're actually hosted on Atlas at Hubba. And so we reached out to Mongo and we said, hey, we're doing this thing. We'd like a bigger oplog. And they were like, sure, here's a 10 gigabyte oplog. So that was the first solution that we used. And then the second solution that we did is to touch a random document in anything that we want to have a history of every hour. And so that can ensure that with an oplog that's 10 gigabytes, Mongo recommends having an oplog that's at least 24 hours worth of data. If you're touching a document every hour, there's always going to be something to resume from. We could have relied on the fact that if we'd fallen off the oplog, that we could just resume and start fresh, but that wouldn't give us that guarantee that we knew our service was working. And so the solution here that we said, as we said, was get a bigger oplog and randomly touch documents. And so there's a bunch of cons to this solution, obviously. The first con that you have to be aware of is histories has no context. It's just listening to an oplog and writing whatever data we write to the oplog. And so if our schemas change, our old history data isn't going to follow that new schema. The second big con is we did spin up a whole new service at Hubba to achieve what we could have done with in-app versioning. It is an extra service, right? There is some cost there. And the third con we had was we did have some upgrading issues. We adopted Mongo 3.6 kind of pretty much when it came out, and we did have some performance issues. Turns out those were related to the driver. And again, working with Mongo, they were able to help us solve those issues pretty quickly, but we did have a couple of issues with the Mongo native driver, but those have actually all been resolved now, and our performance looks really good.
Clearly, there were a lot of benefits that definitely outweighed all of these cons. So one of them is histories is isolated. So as long as our data is persisted, we'll have a history of it. We get to keep all those raw queries that we love so much. So our denormalization strategies will continue to work for us. And then there's language support. So we didn't need to implement history support for every language we use at Hubba. We just use a version generator if we want access.
Cool, so I alluded to our metrics earlier. This is a snapshot in time of when we were deploying this service. And what you can see here is, you can see on the the right of the big spike that while there was that bug in the driver, we did have a little extra replication lag. But what you can see is while we were running through and touching every single document in Hubba in order to issue a change stream event such that our change stream service could pick them up and write those into our history service, we obviously had a spike in our replication lag. But other than that, disk space is the biggest change in our metric. Right now, we're storing all of our additional data and we're storing copies of our data every single time we change a product. And so we are storing a lot of extra data. But that's a good trade-off for us, and storage is relatively cheap.
All right, so here's our conclusion. We're going to do a little demo as well, if Ed's cool with it. So change streams are a great way to follow updates to your documents, as we've proven at Hubba. Using change streams for event sourcing would be amazing. And if you're versioning your data in a legacy app like we were, it could definitely work for you as well.
Cool, so now we would like to try and do a demo. So there's my mouse.
I think you want to go that way.
That way. I'm not coming off. No, it definitely is this way. Really? There we go.
Live demos.
Live demos. So what we're going to try and do here is we're actually going to try and do what we do at Hubba in production live. And so I think that's relatively readable here. And so what we have here is we have our Hubba collection. And in our collection, we have a bunch of users, apparently one. And we've got no messages. And so what I'm going to do here is I'm going to insert a document into this messages table using Compass. And what we should see here is in our histories collection up here, which right now has no messages, we should see the history service pick up that change stream event and write that document out to our history. And so the message I'm going to say here is I'm going to insert a message. We'll say it's to Leigha. And we'll say it's from Ed. And the message will be, how did our talk go? And so if I insert this message into the database, what should happen is a change stream event will fire. And if the demo gods like me, we should see that in the history. So when I click insert, a change stream event's happening. We head over to the histories, and thankfully, we've got this message in our histories database. And so what you can see here is this is the full document that we just sent over. And so just like in our slides, you've got your hash version. You've got a join version. I didn't include a version number, and so our history service actually works fine with that. It just ignores it. Then what we've got is the next thing that's interesting is the operation type, which is an insert event in this case. We store the whole change stream, and then we store the full document. And so if I open this up, you can see that I am messaging Leigha, and you can see the message that I sent to Leigha. And so what's cool about this solution is kind of, as I alluded to earlier, we could go back into messages, and I could be like, no, this isn't what I wanted to say. I wanted to say, how did you think our talk go? But I wanted to capitalize that. And so I could change this to a capital, and I could probably even add back in my version number. And we'll call this version 1. But we do have to set that to a int. And so when I insert this into the database, Mongo is going to fire a replace event, just because of the way Compass works. And then we should see that propagate over to our history event. And so we'll now have 2 messages in our histories database, one which is the original message I sent to Leigha, and then one which is the updated event. So if I click update here, we can now head back over to our histories, and now we have 2 messages in our histories database. And again, we can see the first one here is our insert, and then the second one down here is our replace. And so this replace document works exactly as we talked about earlier. It's basically deleted the old document and just put this one in place. But I know what you guys are thinking. The cool ones are the updates. And so we can try and do that. You can't do that via Compass. But if we pull up a shell here, I can run a message. Oh. I've lost a cursor. Let's just reconnect. So we'll use the Hubba table, and then I will set the from, and instead of a ed, so if we go back to Compass, right now the from here on my message to Leigha is ed. We'll set that to Edward, because I guess we should be formal, and we'll increment the version number. So if we run this raw Mongo query, Mongo will respond back. It will say it matched one document in this case, because we only have one message, but this is what we would do when we denormalized. And it will actually say it's updated that one document. And so we can flip back over to Compass. And if we refresh this, that is not how you refresh in Compass.
We broke everything.
No, we can connect again. And we can zoom in again. So if we go back to the Hubba collection, we can go to messages, And you can see now we've got Edward with the 2 exclamation marks, but that's just Mongo, right? That's not an actual histories thing. You guys don't really care about that. But if we go to the histories database and we look at our messages, you can see here we've now got 3 messages. The third message here is the update event that we just triggered via Mongo. It's version 2. We've now got the fancy SHA. And then what we can actually do is we can look at the document, and the document looks correct. And then the last thing that's cool here is that if we can see it, you can see here the updated fields is just saying the only updated field here was from, which we set to Edward, and the version is what we set to 2. And so that's it for our demo. That's it for our talk.
Do you want to go back to the slideshow?
I beg your pardon?
Slideshow?
I'll try and get back to the slideshow. Questions, comments, queries?
I think they're going to do questions.
If y'all have questions, raise your hand and I'll give you the mic to make sure you can be heard.
Open it.
I don't need to do that today. That's what you're saying.
So I'm wondering if you guys used any broker like Kafka with your change stream?
Yeah, so we use RabbitMQ to process most of our asynchronous messages at Hubba. And so one thing that we actually do is, because we don't want our service that's following change streams to be bogged down, we actually do insert those into RabbitMQ for processing. The disadvantage of that is RabbitMQ is not guaranteed to process our messages in order. And so for the purpose of this talk, we kind of glossed over that. And that's where we really do use that inserted in nanoseconds time. But again, Mongo 4, actually, they will give us a time that we can use instead. And so we're going to switch over to that, because that will give us basically pure durability, guaranteed to know exactly when our messages happen.
Could you please elaborate on what are some of the issues that you faced when the inserts or updates are happening very frequently?
I'm sorry?
You said that if you're having a lot of updates and very quickly or like in nanoseconds, then you could face some issues.
Yeah. So basically, if, for example, you were to set my name from, Ed to Edward to Ed to Edward to Ed to Edward just a bunch of times, even though the update description may say that you've changed my name to Ed, the full document that's durable in the majority of your replica sets may be Edward. And at that point, you'll get a full document that says Edward, even though the update description says it's changing my name to Ed. And that's super confusing. Mongo does mention this in the bottom of their documentation, but that is the issue we encountered there, is that our full documents weren't matching what had been changed. It's guaranteed to match something in time, but not always guaranteed to match that exact update. And I don't know how the internals of it work, but I think what it's doing is basically to generate the full document, they're just doing a Mongo query and giving back whatever has been persisted. Does that answer your question?
So as far as I understand, you guys are using this for replication too, right? Where in your pipeline do you do this, and what is your overall strategy? Do you have for actually syncing data and getting all databases up to the same point? So what I'm interested in knowing is, do you do this overnight? Do you constantly keep streaming, or do you have another strategy? And as you are talking about this, do you already, or do you have any plans in incorporating this into the software CI and CD pipelines, if you have it?
Yeah, so there's a lot of questions there. The changes are live, right? So you're listening to a change stream, kind of as I tried to highlight in our demo and probably could have done a better job. When you modify that messages collection, it's instantly firing that change stream, and it's being instantly picked up and writing that history out to our messages. And that's just a feature of change streams, and that's where the power comes of it, is you don't need to run some kind of pipeline overnight to aggregate your data. If you want to know when something's changing, change streams are providing you with an instantaneous view into that.
I see, but then you have to apply those changes manually, right?
We do, because of the full document issue. If it wasn't for the full document, you could just blindly write that full document out and it would be perfect. But what we have to do is we do have our history service which has it's got an instance running in Amazon that subscribes to that change stream. And then what it does when it sees a change stream come in, it finds the previous history and updates it.
So no batches.
No batches. The only thing we had to batch on was when we first launched it, right? Because we had, a couple of million documents with no histories. We just blindly went through and bumped the version number on every single document, and then consumed those change streams and treated them like inserts, essentially.
Yeah, so as you said that you have a replicated environment, right?
I beg your pardon?
You have a replicated environment, 3 node or 5 nodes, any replication is in place wherever you have implemented change stream. So change stream, when the writes will be taken by primary, and all those writes will be, each write will be converted into 2 writes, essentially.
Yes.
By oplogs.
Yes.
So if the application is very write intensive,
Yes.
then do you see that there is any performance impact on when you guys implemented change stream?
So yeah, definitely. You're 100% right. So if I'm understanding the question correctly, whenever a user now creates a product on Hubba, what used to be 1 database write is now 2 database writes. And then kind of in my demo, we're now polluting our oplog with all of those additional updates, as well as we're storing a lot of data, which may or may not be a good thing. And so the answer to that is you're totally 100% correct. And this was a trade-off that we made in order to get to market quick. There's a lot of strategies we can use to continue to make this more storage friendly and more oplog friendly. Like the obvious example is splitting out our histories cluster from our non-histories cluster, right? That would instantly alleviate the oplog issue. Another thing we've talked about doing is in the future is only storing the updates and then basically calculating that live on the fly and using some kind of caching, right? Because odds are nobody's going to be looking at an order from 4 years ago in Hubba. So there's lots of strategies we can use there. The version we showed you was the first version that we pushed out with a lot of debugging information to give us the confidence that this was something we could do. I'd be happy to talk to you after about some of the other crazy ideas we've had to make this even more performant, but there's definitely is a cost to storage, but there's also a lot of trade-offs you can do to solve that problem.
I guess based on the business requirements, we may also periodically clean up the logs. Right?
Yeah. But at the end of the day, if you're versioning your data, there's a cost incurred with that, no matter what solution you chose to do.
We probably have time for one more question, so let's have a good one. Who has a good one?
We also have a bunch of hats and stickers that we can't bring back, so if anyone wants them after.
Swag is good. Okay, I'm coming to you, sir.
Could you talk a little bit more about the normalized data that you mentioned and why you chose to go with using the driver versus something like Mongoose?
That's all you.
Sure. So denormalization is a strategy that Mongo kind of encourages, right? I know they have lookups now that you can use to join your data. We're a 7-year-old company. We've been using Mongo before they had lookups, and it's actually amazing at how quickly Mongo does add features. But so, for example, in our messaging app, if we wanted to display the username and the company that they were associated with, and we didn't want to do an additional query every single time in order to get that, denormalization is the strategy for how you handle that. So whenever our user changes their company or their name, we would then do a select on all of our messages and update that user's name so we can display that to the user without doing an additional query.